Hello everyone. In this video, let us see the arrangement of ions in the ionic molecule. How the ions will be arranged. Arrangement of ions. In order to understand the arrangement of ionic species in ionic molecule, we need to understand one point that the electrostatic force of attractions are non-directional. They don't have a particular direction. They can attract its counter ion from all the possible directions three-dimensionally. Not only from front side, not only from back. It can attract its counter ion from all the possible directions three-dimensionally. So by this we can understand that these ions will not be existing as a pair of atoms or a pair of molecules. So if you take the crystal of sodium chloride, it will not be having a pair of NaCl, NaCl, NaCl like this. Each Na plus will be surrounded by a specific number of chloride ions. Right. So depending upon the size and the charge present in a particular ion, cation, the number of counter ions, anions will be bonded to it, or that will be attracted to the cation. Right. So let us take the example of sodium chloride crystal and let us try to understand it. So if you look at the sodium chloride is a cubic crystal. It is a face-centered cubic crystal. Face-centered cubic crystal. Right, in this way, this is a cube. Now, at each corner of the cube, the chloride ion will be arranged. These big sized atoms are what? Chloride ions. And they will be attracting their counter ion Na plus. This is the small sphere is Na plus and the larger sphere is Cl minus. You know that anion is bigger than cation. Just with that concept we are showing that between every two chloride ions we are representing one Na plus ion, right? Here also in between these two. Now these will be bonded to each other. Here also one sodium ion. Okay, now between these there will be, this is a face. Now by joining this they are forming a face of a particular side. So this is a topmost side, this is forming a face, and in the center of this face there is one chloride ion. And now again if we join these also, we get one more center at the face. These atoms, these ions which are present at the center of the face, they will be joining each other. Now again see here, they will be bonded to each other and they will be forming a bond like this. So at every center of the face, this is the top face, this is the right face, left face, bottom face, and this is a front face, and this is a back face. The center of back face is this. These will also be connected to each other. Right. at this center again then we having one chloride, Na plus ion. So in this way, this sodium chloride will be arranging their consonance ions in the form of FCC, phase centered cubic crystal, phase centered cubic crystalline structure. Right. So what is the phase FCC? Let us I'll brief you now. This is a cube. You know the cube consists of 6 faces: the top face, bottom face, left face, right face, front face and back face. And there are 8 corners with 12 edges with a center in it. Right. So here these chloride ions are arranged at the center of every face. So therefore it is known as phase centered. See here, there is a chloride ion in the center of this face. This is a top face. Top face. This is a left face, right face. So let us take a small cube and we can understand that. What is a face? I will represent the face now. This is a small cube. Right. So this is a face. Top face. Right. This is a bottom face. Right. If you take one more cube, you can understand the left and right faces. Left and right. Top and bottom is over. Now let us see again front and back. This is a front face and this is a back face. See, I will show like this. The back face I will show with the cross lines. Right, front and back face. This in the center of these faces, if you observe, you can find an ion. See, in the center of this face, you can find a large chloride ion. In the center of the top face, you can find large chloride ion. Here, front face, back face, bottom face. So this is the reason why it is known as FCC, phase centered cubic crystal. If we also have body centered cubic crystal and primitive cubic crystals, you will be studying about these in your higher standards. In the solid state topic, you will be studying about this. So this is how these ions will be arranged. See, around every ion, if you look at this ion, this chloride ion, 1, 2, 3, 4, 5, and at the top continuation you will find 6. So every chloride ion is surrounded by how many Na plus ions? These are Na plus ions, isn't it? This is Na plus ion, 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 this is also Na plus ion. So around one chloride ion, 1, 2, 3, 4, 5, 6. 6 ions are bonded to it. So right, in this way, every ion in the sodium chloride will be surrounded by how many? 6 chloride ions, 6 counter ions. This number we call it as coordination number. The number of bonds that an ion forms in a ionic molecule is known as coordination number. Right? The coordination number of NaCl is 6 because every ion will be surrounded by 6 ions, 6 counter ions. Now let us take the example of this anion, this Na plus cation. See here, this is surrounded by, at the front face there is 1 Cl minus, at the back there is second, at the left there is third, at the right there is fourth, at the top there is fifth, at the bottom there is sixth. So in this way, this Na plus ion is surrounded by how many totally? 6 chloride ions. Right? Therefore, the coordination number is what? 6 ions. Based upon the size of the cation and its charge, the coordination numbers will be varying from one ionic molecule to another ionic molecule. Right? So this is about the arrangement of ions in the ionic crystal.